Let's look at an application of finding the distance between a point and a line. So Aria's playing a pool game, so it's a video game on her iPad. The playing surface is represented in the game by a rectangle that has opposite corners. This corner is placed at the point 0, 0. This corner is placed at the point 150. And so this is just a rectangle that's placed in the first quadrant. Okay, she's going to hit a cue ball that's positioned here. So we've got a white ball here that's placed at the point 2516. So just using the grid that we created in quadrant 1. She's trying to hit the target ball, which is placed at the point 7546. Okay, so now she's decided that her shot needs to be at an angle of 30 degrees with the horizontal. So looking at her, this is our horizontal. This is her line of shot that she's going to make. And it's going to be at an angle of 30 degrees above that horizontal. Okay, so her goal is to find out if she's going to hit that target ball. And so what we're going to do is we're going to assume that her line of shot is the line L. Okay, so we need to have a vector that's parallel to that. So V is a vector that's parallel to her line of her shot. Now we know it's at an angle 30 degrees above the horizontal. So we can assume that the coordinates of that point would be cosine of 30, sine of 30. Okay, just thinking about the x-axis, and if you know it's 30 degrees here, the coordinates, the cosine, of course, you can assume that thing has length 1. So it would just be cosine of 30, sine of 30. Okay, which will be square root of 3 over 2, comma 1/2. Okay, we just want a vector on that line, so we're just assuming it has length 1, which is why we know the coordinates are cosine 30, sine 30. Just think of a unit circle. Or use your right triangle and figure out the x and the y. Okay, so that's the vector v that's on her line of sight. And now what we want to look at is we want to look at the line that would go from P to Q. So P to Q up here. We're hoping that it coincides with our line of shot, but we're not sure. PQ, though, is easy to determine. Just find the components of the vector that pass starting at P to Q. So it's going to be 75 minus 25 is 50. 46 minus 16 is 30. So what we want to find out is what is that shortest distance from PQ down to her line of sight, the vector v. So we'll assume that this is the line L where her line of sight is. V is just a vector that was parallel to it. So now we're going to look at that shortest distance. So we'll take the perpendicular distance from Q down to that line. So it's going to be this distance right here. So we know how to find that distance. That distance is just going to be the magnitude of V cross PQ over the magnitude of V. Okay, so we need to find the cross product of V and PQ. Now those are vectors in the XY plane in 2 dimensions. So to use a cross product, we have to make them 3 dimensions. So we'll just put the kth component 0. The Z coordinate would be 0 for each of those. So the cross product okay, so the ith component will be 0. The jth component will be 0. And then the kth component will be 30 times the square root of 3 over 2. So 15 times the square root of 3 minus 25. Okay, so if we want the magnitude of that cross product, it's just going to be the magnitude of, well, it's just going to be that k component because it's just the k squared and then the square root of it. So it's just going to be 15 times the square root of 3 minus 25. The magnitude of the v, now we chose v, if you just find the magnitude of this, the magnitude of v is just going to equal to 1 since we assumed it was on the unit circle. Now this distance is approximately 0.98. Okay, so now we're trying to get our cue ball to hit that target ball. Now it's okay if there's a distance from Q down to that line of, her shot. What we want is we want it to be close enough so that the two balls collide. So if we had two balls here, and they're assuming that the center of the ball is where the point's location's at. And if each ball is 2.25 inches across, that means this distance is 2.25 and this distance is 2.25. So as long as those two centers of the ball aren't greater than 2.25, those balls will collide. So this would be if they just barely touching, then that would mean the distance between them would be 2.25, the distance between their centers, since that's the width of the diameter of the balls. So that means then if our distance between her line of sight and the point Q is 0.98, that means the balls will collide. Okay. Now from there, if someone actually wanted to do some more calculations, once they determine that, they can actually determine where the balls are making contact with each other and the direction each of them would go after they've been hit. So while this looks like a video game, it actually is something that's used when you're doing some flight simulations. So when you have people in the military or civilian pilots, they can do, it's used in this same type of technology, the mathematics is used in flight simulation. It also is used when they're training surgeons for surgery. So it's a very, applicable idea. So let's see, this shows the line of sight. And so we just want that distance between the two centers to be less than twice the radius of the balls, and the radius was half of 2.25. Okay, so all we were doing is looking at her line of sight, and the only way that she's going to miss the ball is if the distance from her line of sight to the ball is greater than that 2.25, assuming they were at the centers.